By learning how to find a consumer's optimum consumption bundle, you know how to formally derive the demand curve for that particular good. If you remember from chapter number 3, we derived demand curves by ordering willingness to pay from highest to lowest. However, that's kind of the simplistic way to approach demand curves. The more formal way, the way that economics should show you how to derive demand curves, is exactly through the process of what we just did by taking a look at the optimum consumption bundle. So let's go ahead and see how we derive demand curves by changing things up just a little bit. So how would consumers react if the price of a good changes? And intuitively, if the price of a good is going to change, it's also going to change the consumer's optimum consumption bundle. If the price of a good increases, you're probably going to buy less of that good. If the price of a good falls, then you're probably going to be buying more of that good just due to the marginal utility per dollar having more bang for your buck. So what we want to go ahead and do is see how a price change alters the optimum combination of goods and how it's going to be drawn along our demand curve. Remember, anytime we change the current price of a good, it's a movement along the demand curve. It is the law of demand. We do not shift our entire demand curve. We still remain on the same exact demand curve. So suppose that we change the price of wall climbing by $5. So we increase the price of a half hour of wall climbing from $10 to $15. So this price is going to be reflected right here. But everything else is essentially going to remain the same. The price of pizza still remains the same. We have $50 in income. So how does this change our optimum consumption bundle based on the problem that we've been working so far? If you remember, our original optimum consumption bundle was 2 pizzas and 1.5 hours of wall climbing. However, when we increase the price of wall climbing, you notice that the marginal utility per dollar, your bang for your buck, is also going to change for wall climbing. So here, when we take this 90 for marginal utility divided by 15, we get 6, we get 5.33 when we divide it through by 80, and then so on down the line. So the only numbers that are changing is column number 8 because we've changed the price of wall climbing. We've increased it. So all these numbers right here have gone down from what we previously saw. So how do we find our optimum consumption bundle? We do the same techniques. If you were the rational consumer in this instance, where would you spend your first money? Pizza or wall climbing? Now you would go ahead and spend your first money towards your very first unit of pizza because 7 is bigger than 6. Remember before, you would spend your first money towards wall climbing, but now because the price of it has increased, you are now having a bigger bang for your buck with pizza. So you spend your first $10 for pizza. Then where would you spend your money? Doesn't matter if it's wall climbing or pizza because the numbers are the same. So let's go ahead and say you spend your next money here for your second piece of pizza and your next money for wall climbing. So here you get your first unit of wall climbing. So far we spent $20, $35. So where's your next money going to go to? It's going to go to another half hour of wall climbing. So another unit of wall climbing. So here 5.33 is bigger than 5. Therefore, we have successfully found the optimum consumption bundle. It's going to be 1 hour of wall climbing or 2 units of wall climbing and 2 units of pizza. So we've spent all of our money. We are optimizing our bundle here. So one thing that you've already noticed is that, hey, these two values are not equal to one another. The marginal utility per dollar for pizza is not the same as the marginal utility for wall climbing. So I thought we can't be utility maximizing at this point. And this is true, but we have to make a big simplifying assumption right here because we are working with discrete numbers. The real maximum would actually be just a little bit more than 2 pizzas and just a little bit under than 1 hour of wall climbing. However, with the quantities right here, you'll notice that we are working with discrete numbers and not continuous numbers. In order for us to find the actual, the very specific or exact amount for each of these goods, we would have to use a little bit of calculus and use continuous numbers in order to find that exact number. And I'm pretty sure you guys don't want to learn calculus. So here we just use that simplifying sort of assumption that we are going to be working with discrete numbers here. So just go ahead and work with this in this particular example. So the optimum consumption bundle is going to be 1 hour of wall climbing and 2 pizzas in this instance, and that has changed from our previous bundle where we had 2 pizzas and 1.5 hours of wall climbing. Because our optimum consumption bundle has changed, that is also going to tell us that, hey, we are going to be shifted up, or we're going to be moving up along the demand curve in this instance. So at point A right here, before this was our optimum consumption bundle where we had 2 pizzas and 1.5 hours of wall climbing. However, when the price of wall climbing increased, remember that's going to pivot or rotate our budget line or budget constraint inwards, making fewer choices available, making combinations of both of these goods having a fewer choices among both of these. Our new optimum bundle is going to be at point B, where we have 2 pizzas and 1 hour of wall climbing. And as you can see on the graph on the bottom right here, we're graphing the demand curve for this particular good for wall climbing, and it matches exactly with our optimum consumption bundle. At $20 for wall climbing, we are going to be consuming 1.5 hours. But when the price increases to $30 per hour or $15 per half hour, we're only consuming 1 hour of wall climbing. So this change in our optimum consumption bundle and the optimum choice is going to be reflected with a movement along the demand curve. And this is exactly how we derive demand curves. If we go for every single price for this particular good, we're going to see this downward sloping demand curve once again, the law of demand and action. So from all of this, this is going to be the most formal way of how to derive demand curves. It is utility maximization in a crux. So as you can see with all of this from this setup that we have, we are able to see that the demand curve is going to be derived by consumers' optimum choice bundles. And basically, when we change the price of a good, it is going to be reflected with a movement along the demand curve by changes in the optimum consumption bundle. So we can do away with the willingness to pay sort of analysis that we laid out in chapter number 3. And now you guys know exactly how to formally derive our demand curve in the most traditional way that economists like to use. And it will be very applicable in your higher level econ classes as well.